All right, welcome, welcome, welcome. Let's get started. Let's get started. All right, so today, we're going to cover chapter 3 of the Making Sense of Teaching Mathematics. So, we're going to get started by going through some of the details and some of the new stuff that I'm going to offer in the Mathematics for Change book. So if you've read chapter 3, I'm going to go over some of the details, do some of the summary. If you haven't, that's perfectly fine. We'll go through some of the details and some of the applications in this webinar, but you can also ask questions and things like that, and I'll see the questions and I can answer them as we go through. So what we're going to start with today is going over some of the new changes and things like that that's happening within the book club, and then also how we're going to transition to talking about distance learning, because there's going to be a mixture of both happening, where there's some schools who are going to do just strictly visual learning, and then distance learning, and then some are going to do a blended model. So we're going to kind of go into that a little bit, and I have some really cool apps that you can use in your classroom for your students online and also in the classroom. So for next week, we're going to cover chapter 4, which is on functions. So we're going to go into that. And that one is going to be a two-part kind of webinar, mainly because it's a lot of content. And I want to make sure that you're able to provide scaffolding for that chapter, because there's a lot to it. I debated on whether or not I should split chapter 3 into two parts also, because there was a lot of content that was covered. There's also one thing I'm not going to talk about in this webinar today, which is systems of equations. So I'm not going to go into that into too much detail. But if you would like to know more about that and provide more resources for that, I will definitely make sure that I provide those resources for you. So we're going to get started. We have a lot to do. Lot to do. So one of the first updates that I have is that there's going to be a new website with all of the materials and resources that I talked about in the Facebook chat, where you can access all of the visual math material. So let me show you what the website looks like and what is accessible through that website. So there's a bunch of materials. So this is the layout. And what you'll have is it'll give you updates on the webinars for each chapter. And then it'll have the instructional videos here. And there's a playlist that you can actually access to learn how to do the different methods. Then there's a subscription you can sign up also, so you can get updates on when the new resources are available. And then there's 3 options right now. So the first one, most of you guys probably know about, which is the Mathematics for Change. And this is basically the book club where we go into the different details about how to apply mathematics and how to help students who have special needs and ELL students as well. And then I'm making a lot of updates to the visual mathematics membership. Some of you have already subscribed to that. That's really great. And that will also provide different types of resources for providing remedial math support for middle school students. And then we have the Middle School Math Adventures channel. Also, you have access to that. And then there's me. And then there'll be some instructional posts on the page as well. This will go into how to teach the different types of lessons to students based on their level. Also, I'm going to include some things about assessments as well, so you can look into that. There was a new one posted yesterday where you can see 3 tips for using the TQE method online. And again, like I said before, we're going to shift gears to talking about online and distance learning to mainly help support those special needs students online with mathematics who need that remedial support. So this is going to be access. You can access all of these resources And I'll include this in the description of this video if you would like to access some of these details. All right, let's shift gears here. All right, so let's talk about the overview of chapter 3. So chapter 3 goes into equations, expressions, and inequalities. So what happens is they go through the progression of starting off with how do you start with the equations in the 6th grade. So how do you scaffold teaching students about variables? And then also for the next part, it talks about how do you transition from going from learning about individual expressions to equations, and then to linear equations, and then to inequalities. So there's different steps to the process where you can access, and the book also goes into all of the details, and this is what the book looks like if you haven't got access to it. So we're going to go through each of one of the different steps. So in this webinar, I'm going to cover a couple of different things. So the first thing I'm going to cover is the introduction to algebra. Then I'm going to go into the linear equations, and then how to apply the TQE method. And within going over the content, I'm going to talk about some different types of resources you can use online that are available to you, and how to access them. So the first things first, in terms of how the chapter lays out the concept of teaching equations, inequalities, and expressions, is first of all, I would start with teaching students one concept at a time. Diving right into teaching students how to do the conceptual stuff at first is going to be very confusing if they don't have any background in algebra. So I would even start with teaching them what is an expression, right? What is an equation? What is an inequality, right? And why do these things matter? So I would give them sample questions just to see what they look like. And also being able to understand what, when you add a letter to something, what does it mean, right? And this is also when you get into algebraic word problems, there are some different aspects that students are not clear on. One of the things I saw, like with my students in Algebra 1, is they didn't know how to translate the expressions into words, right? And they didn't know how to translate the words into the expressions. So teaching this like in the 6th grade is like important. And I'm going to go through and show you one of the other resources that are available. So if you're not familiar with Gizmos as a math teacher, you need to be, because this is like the best website ever. And basically what you can do is on this site, it's provides a whole bunch of different resources and worksheets as well. So if you are a member and you're subscribed, you can access the teacher handouts and reference sheets. But if they have a 30-day like trial that you can utilize as well. But this is an excellent resource, mainly because you can model and the students can also do it with you. So if you start here, right, it says model the expression 3 plus x. And then what you'll do here is you'll write down the 3 plus a number, right? Okay, so students are able to practice what this actually means. And this is also informative for scaffolding for your ELL students as well, because they'll be able to see how to learn about and talk about the words that are associated with expressions when you do your number talks. So this site is important. Mainly this module is called Using Algebraic Expressions, and students can actually practice this skill set, okay, along with you, and you can give different types of problems. So this scaffolding is 100% necessary when you're talking about introducing expressions and equations. So we're still going through the overview. So the next one in the chapter, it goes over the staircase, right? So it provides students with a staircase model, and they tell you, okay, if these numbers are associated with the first, the second, and the third, right? What is the 10th model going to look like? And this is kind of helping students translate the concept, right, into something visual, which is important. If you read chapter 3, they start with that. In terms of the instructional methods, I wouldn't start with the modeling in that way. I would start with going over what is an expression and what is a variable and how do you write expressions, and then maybe later on conceptually the students can understand. If you want to start with that model, what I would suggest is not going right into the algebraic expressions, so that students are able to really understand the different parts of the problem so that they can apply it to the modeling. So let me just fix this here for a second and make this as clear as possible. All right. Make sure. Okay. All right. So here, the next part that's happening is that we're going to go into, right, what sufficient scaffolding actually looks like. So within the text that you guys read, right, they talk about how do you get from the model to the actual learning about the expressions, right? So what you'll do is have students discover the answer, right? So for the model that they constructed, and I'll show you that really quickly so that you can get an understanding of what I'm talking about. But the model that they presented, okay, so the model that they presented is this one, right? And they're starting with these blocks, and they scaffolded these different types of staircases. And what I would do is I would provide students with those four staircases, and then I would give them a fifth one. So how many blocks are in this fifth staircase? And that's pretty simple because they can draw out based on the previous models what the fifth model is going to look like. So once they have that down, right, then I would have them make a table. And in the table, they can write down, so the first model, they have this many blocks. For the second model, they have this many blocks. So the students can kind of see the relationship between the model and then the amount of blocks. Then what happens is what is the difference, right? So what is the difference between model 2 and model 1? What's the difference between model 3 and model 2? So you're actually building their understanding so that students can see the relationships, and then you can add the variables in at the end, right? So how do we figure this out using an expression? And in the text, they use specifically N+1, the recursive thinking type model, where they're using the different types of previous models to build on the next one. So these are the methods that they often use to teach students about how to write expressions. But what I would do is definitely provide that scaffolding first, and then allow students to dive into figuring out what the expressions are. All right, so the next part, let's talk about Intro to Algebra and why it's important to provide a basis for this. So algebra can be like a really abstract concept for some students, mainly because they don't have the foundational knowledge. So what ends up happening is you'll start off in probably like 6th grade where you'll have expressions, right? So you'll have something like 8 plus what equals 11, right? And you're not going to put anything in the blank, right? And students have to figure it out. So they'll understand, okay, whatever goes in the blank is what X is. And then you can add the X's and you can add the variables. Then what I would do is teach equivalent equations by doing the same thing. So 8, right? And then so we have 8 plus 3 and then 5 plus 6, right? Right, those are equivalent, right? Because they equal each other. They both equal 11, right? So that's how we teach that concept. And then continue to provide that scaffolding through 7th and 8th grade so that they can see the relationship between the different types of concepts. And we're just literally replacing that blank with an X or a variable. And then also at the end, then I would go into a little bit more details about word problems. If I would provide a task using the TQE method when I'm first teaching the algebraic expression concept, I would not start with a word problem. because students need that basis and that scaffolding. So one of the sample word problems that I thought about was you are cleaning your desk at school. You find you have 6 times as many pencils as highlighters. Write write the number of pencils in term P in terms of number of highlights, which is H. Okay, so I gave the students 2 variables, right? So how would you figure out, right, if you're cleaning out your desk, if you have 6 times as many, um, how many highlighters are you going to have, right? And then they have to write the expression for that. So that enables them to actually figure out how to set the foundation by starting out what is an expression. And then students can understand that variables correspond to numbers, right? So, right, if they have this many pencils, this is how many highlighters they're going to have. Okay. And I would go back and forth between providing numbers and providing variables so that students can see the relationship. Okay. And then I'm going to go into really quickly some of the models that I'm going to show here. And I really love these. If you're doing any form of distance learning, let me go back to the equivalent algebraic expressions. And this one is really cool. This is on Gizmos, and they provide different levels. Collect as many stars. I'm going to go back on this one here so that you can see it from the beginning. But this is equivalent algebraic expressions 1. And this one is so cool, mainly because you can utilize the different types of scenarios here. So, okay, so it gives you a little scenario. Students can go through this, right? And then they can do these little scenarios, right? Where they have 5 plus 11, 8 plus 8. You can click equal, and it does it for you so that they're practicing these equivalent fractions. Hold on, let me just log in for a second so that we can keep this going here. And a nice thing about this is you can send individual modules to your students so that they can work on the different problems, and then you can check their answers, because at the end of the module some of these have different types of questions, and you can check for understanding with these as well. And then I'll talk a little bit about how you can scaffold for that. Another thing is actually using this app called Braining Camp, and this is where they have all the online manipulatives. And you can use this to demonstrate the concepts to your students. Now, when you talk about algebra, right, you want to use these algebra tiles. So they have these tiles, and you can start teaching students about how to use these and utilizing them for modeling different expressions. So then it makes it real, because students will be able to see how the blocks correspond to the different parts of the expression. So then the next part, right, is we're going to talk about is linear equations. So let's talk about linear equations. So linear equations is basically kind of a combination of different concepts. So students started learning about like fractions and proportions and ratios back in like the 5th grade, 4th grade. And this is where we're coming back to this concept of the relationship between a ratio, which is the slope. So students usually struggle with this because there's expressions, there's different types of equations, there's graphs, there's all this other stuff. But you want students to really focus on the visual, and then also getting them to understand that the variable x changes with different numbers, and I think that's why important when we go back to going over word problems and things like that, emphasizing the point that variables can change, and that means that not necessarily the equation changes, but the result changes. And then we go into functions, which we're going to cover during the next webinar. Then students will understand that concept as well. So what I would utilize for teaching and starting to teach linear equations is what we call Desmos. So Desmos is basically a graphing calculator that's completely free. Students can access this, teachers can access it. It also has a different modules and things like that on the Desmos program. So students will definitely be able to utilize this online. And basically what you can see, I'm just going to zoom out again. You can see the relationship. So I have 2x minus 5, right? And students can identify this as a linear equation, right? Because you have the x, right, in the equation. And you usually have a number in front of it, right, which is a 2. And then you have the b, the y equals mx plus b form of the linear equation. So here what you'll have is you have the positive, which is in red, and the negative. And that's really great because so students can actually see the different relationships and they can look at this. And I would post this. I would start with the graphing mainly because then the equations will make sense. So I always like to start with the visuals. So students would be like, oh, ask students like, what is the difference between the red and the blue line, right? And then what is the difference between the different equations? And students will point out that there's positive 2 for the red and a negative 2 for the blue. So I would start with that and then presenting it as a way to be like, okay, so the equations kind of dictate what the graph looks like, and providing that scaffolding between the equation and the visual, and then applying the concept algorithmically. Okay, algorithmically. I can't pronounce that word. So the procedural knowledge is what they call it, which is usually what, how everyone was taught to do equations, is where we usually start from. And that is kind of doesn't help students learn conceptually what the graphing is. Graphing is usually taught usually last. So this once I flipped this method with my students, with my Algebra 1 students, they were able to see the relationship between the graph and then the equation, right? Because the graph is a representation of the actual equation. And then you can do some system equations there where they cross at a specific point in the visual. So what I would do for the linear equations, remember that always think about the visual first and then building up to the procedural, but always connect it back to the visuals. And students will love playing with Desmos and writing different types of equations. And I've given students scenarios like, okay, can you try this type of equation? What does it look like? And describe what it looks like, right? So they can go back to expanding on their knowledge of coordinate planes, right? Where does it cross? Where did the lines intersect? And you're going over these different concepts as you are teaching them about linear equations. So everything is cumulative. And if you go over the concepts in a cumulative way, the students will be able to recall the information a lot better. All right, so the last thing I'm going to talk about is the TQE method. And this is something that I take pride in, mainly because it's way different than most teachers teach this concept, mainly because it takes a lot of effort and work to think about how did these connect and what are the students thinking. And it's very free flowing because the students are dictating what the information is. So TQE stands for task, question, and equation. It's task, question, and evidence. So evidence is the last and the most significant part, mainly because students get to be able to present the information to the class. So, but the scaffolding for the task and the questioning part is most important, where the teacher needs to set the students up for success. So in these scenarios where we're talking about equations, I would start off with the graph or the visual, okay? So students are looking at this visual and they have a set of equations if it's applied or not, but they have a scenario where it is a question and they have a visual. And you're asking them in their groups to figure out what the concept is, right? So students then go into the questioning phase where they're asking questions, they're talking with their peers, and this is where the group work happens. And the teacher goes around and speaks with each group and tries to help them think about the problem, not give them the answer, but think about the concept as a whole. And then the last part, like I said before, is the evidence where they're sharing their different methods. And teachers can be conscious of what methods students shared in the questioning part of it, because then you can get a more rich discussion when everybody is able to share their knowledge and how they did it. So the first thing that sets students up for success for using the TQE method is providing a number of different visuals and materials. I know some teachers will provide students with the materials, but usually I'll have a bin in the middle of the desk where students have access to colored pencils, toothpicks, colored paper, whiteboards, markers, so that they all can access those materials when they're solving problems. So they can use any material that they would like. And this allows it to be more visual and hands-on as opposed to just doing a simple worksheet. And the problem will be one problem and it's posted on the board, and students are in their groups asking questions and trying to figure out the answers here. Okay. And then students are expected to do these things called number talks. And I'll talk more about those number talks um, in other webinars and videos, because that part of it is where you want students to build that knowledge. Hide this here. Is where you want students to build that knowledge of the concept. So it's connecting the actual math right into the oral form so that they're able to practice how to talk about the math concepts. And that also research shows that students are able to conceptualize and understand and remember the math content a lot better when they're doing these number talks and they're talking about the mathematics. So in that time, you want to encourage as many students as possible to utilize their voice to solve the problems. So if you have students who struggle with writing or struggle with speaking and things like that, you want to use some assistive technologies for those students to be able to support them through the process and provide enough scaffolding for the students to be successful having these conversations, because you want everybody to be involved in that process. Let's see here. So the next part is also the part that was brought up in the text, and I thought that this was interesting, that the teacher has to really have a really strong understand of the conceptual part instead of the procedural part. And I thought that was interesting because the TQE method really focused on the conceptual more than the procedural. So I want to provide you some tips to help you with moving from that procedural knowledge, because that's how we were taught, into the conceptual knowledge. So one thing that I like to do is I like to think as many ways as possible that I can solve the problem during my prep. And you're not going to hit all of them, but you want to get an idea of how students would probably think about it. And then you want to write down some of the misconceptions that students are going to have about this problem. And then you want to address those problems right in the beginning. And there's might be some that pop up, but there shouldn't be anything that you're like confused about or don't understand. And then you can, at the end, when students have shared their evidence, then you can bring them together and then bring all of the different concepts and show how they're all related. So you want to make sure that you know the different methods, and that's the most important part, because students will definitely, with the resources and things that you provide, have a different way of solving the problem. Um, so if you have any students who need accommodations and things like that, make sure you think about that ahead as well, so that they're able to do the problems, and make sure they have access to the resources that they would prefer to use or would like to use during that time. So it's a really collaborative and supportive method here. So I have a post that I showed before that talks about, let me go through this, the TQE method online. I'm just going to go to that really quickly because I put a lot of robust information in this post, mainly because some teachers have asked me how do we use this method online, and this provides the previous video that I went over on the TQE methodology, and give you some instructional tips. And then I'll have a separate webinar about this as well and how to apply it online. But this goes through how do you go through the conceptual, how do you get to the conceptual in an online environment, because it is very different. So I provided the visuals, right? And then how to guide student to student conversations when you're doing the questioning, because it's also a little bit different here. And then also how to understand the sequence progression, because you want to map out which skills you want students to be able to learn and do within each context. So I would start there. If you can align the different standard progression in your lesson planning, that would be great as well. So this is how I like to map these things out. And then that's how we go through this process. All right, so thank you for joining me during this session. And chapter 4 will be next week, and I'll announce that within the Facebook group. And we can go through some of the different questions. If you have any more lingering questions and things like that, you can ask me on the chat in the Facebook group so that we can go through those different questions, because there was a lot in this chapter. There was so much. So let's go through that. And I hope you're enjoying reading the Making Sense of Mathematics for Teaching book. It's really a great resource and really helping, personally, me think about how to teach mathematics in terms of the standards, and also making it more conceptual for my students, especially in the middle school grades, which is so critical. So I hope you guys enjoyed today, and I hope that you're able to join me next week. Thank you for your time, and I'll see you guys later.